Well, hello everybody. Welcome to week 5. I think on the syllabus it's actually listed as fire streams, but in reality what it comes down to is what we're going to talk about is fire hoses and nozzles. It's not a really long lecture. We're just going to go through a few things. Well, 37 slides, so maybe it is going to be a long lecture. We'll see. So with the basics of fire hose, I guess to start off, fire hose has two different couplings. We're going to get into that. And it also has the hose part itself. And usually what the hose part is it is a rubber hose. And a lot of times, especially for the fire service, but also I've noticed a lot in plants as well, it's like a jacketed rubber hose. So around it will be some sort of fabric that covers it to help protect the hose itself. When they talk about the hose measurement, they're going to talk about the internal diameter. So obviously as this expands, if it's flat, it's going to be probably longer, but once it fills up, it's going to give whatever the internal diameter is. Your common sizes are 1 3/4 inches, which would be your small lines, 2.5 inches, next size up. Some places use a 3-inch line, and that's kind of what shows here, and some places use like a 5-inch line. Usually the 3s and the 5s, what those are supply lines. It's not going to be something that's really used that often in industry unless they have a fire truck. But otherwise, that's what it does. They use like a 3-inch or 2 3-inch lines or a 5-inch line to feed water into the fire truck. There are both male and female parts. So the male part has the threads on it. The female has a swivel on it. There's if you look, there are no lugs here. There are lugs on the male part. The reason for that is this helps if. Imagine you're a firefighter and you get lost and you can find a fire hose but you don't know exactly where it leads. It's set up this way for a reason. The idea is if you find a hose, you know if you have a smooth part, you have a lug, and that's going to take you the rest of the way to the truck. The way we learned it was smooth bump to the pump. So it's that's what those are there for, and it's set up for a very specific reason that way. Then there's also non-threaded couplings. You don't see a lot of the quarter-turn couplings in the fire service. The one below that is stores. That is getting very popular, and again, that's used to supply water to the fire engine itself. When we start looking at taking care of hoses, you got to make sure you wash them, especially if they're being used. We're going to see this when we come on the fire grounds. We're going to have fire hoses. You're going to use fire hoses, and afterwards we're going to clean the fire hoses because that's how we make sure we take care of them. The one on the left is the tried and true method of you wash it down with just another hose. Just wash it, have some water, have some soap, and maybe scrub it a little bit. The one on the right can be pretty complex. It looks really, really neat. I've never actually seen anything like that. But it's just one more option that's out there. But you have to keep your hoses clean. And again, for us in industry, it may not make that big of a deal. But imagine as a fire department, you fought a fire and you've gotten some combustible material on your hose. You pull that hose to the next fire, and all of a sudden it ignites. So you have to make sure your hose is clean on a regular basis. And then drying is just as important. There's a lot of different ways. This is like a drying rack. It's basically blows cool air in. You see these aren't coil tight. You have plenty of space in between the different lengths of hose to make sure the air circulates. That's one way. It could be something as simple as you drag them to the top and just let them drip dry. I've seen that done as well. And then storing. Typically what's happened is it's mounted either on a rack like this, it's mounted on a stand, but you have to make sure that it's stored correctly. This, especially for industry, a lot of your extra hoses are going to be stored this way. You don't want them on the ground because you don't want the connections to get damaged. You don't want them to get dirty. You don't want the jacket or the hose itself to get damaged. You got to remember, if we're to the point of using a fire hose, we're probably not using it just to wash down a piece of machinery. If we're using a fire hose, it's to put out a fire, and you want to make sure that it's there for you when you need it to be. They do have the capability of being damaged. Again, this is just another picture shows the male end and the female end. These can be damaged though, especially the male end. the threads are real susceptible to damage. And that's why we have to really protect those. One of the ways to protect them is when we do roll the fire hose, and this is one of a lot of different ways to roll fire hoses. This is certainly not the only one. We roll it with that male connector on the inside. The female connector can be hit, bumped, whatever, and it's not really it's not that big of a deal. But the male connector, we got to make sure we protect that. And this is one of the ways we do it. And you'll see when we do get to the fire grounds and we're to the point when we're done using the hose on the first day, we're going to roll them up, and we're going to roll them up like this to make sure we protect them. So now we're going to get into operating hose lines. Now, all of these can be operated by one person. It's a lot easier with two people. And this is just basic stuff. This isn't, we're not going into buildings or anything like this. It's just handling a fire hose. So you see, the one on the left, the firefighter in the red jacket there, you see how much he is leaning into the hose. The reason is because he doesn't have anybody there to back him up. And there is the one of Newton's laws is for every action there's an equal and opposite reaction. It's the same thing here. As water's flowing, the force of the water's flowing here, it's also pushing him back. That's why he has his leg straight back like that. So it is difficult to hold on to that fire hose. The one on the left, or I'm sorry, that was the left. The one on the right, you see that those two firefighters in the black turnout gear. The one is holding it, has it right tucked underneath his arm. He's holding on. It's a pistol grip nozzle with his right hand. His left hand is holding the bail. Then the one behind him, he's the one really taking the brunt of that. If you notice right here, I think you can see my cursor. Right here, you can see his hand, and his arm is actually right along the the middle of the other firefighter's back, holding him up as he's operating the hose. Now these are hand lines. These are probably 1 3/4 hand lines. They're fairly small. As we start getting into larger fire hose, the 2.5-inch fire hose, that's difficult to use. I mean, it's hard to handle them. So you look at the one on the left, the one firefighter. Actually, what's happening is he's looped it underneath himself. So now he's sitting on it, and he'll hold it up and spray it. You're using a hose like this for something that you need a lot of water on. Garage fires, industrial fires, something where you're not worried about saving the building. You just want it spread. You just got to dump a lot of water on. You'll go and put these kind of hose lines as. You'll use the small hoses, the 1 3/4 hoses. You use those for smaller lines. Inside, you're going to be doing that for your structural firefighting and stuff like that. So the one on the right with large, you see you have two firefighters. What they actually have is they have a belt. A lot of them carry belts. I always did. And you loop it around the hose. You put it around your shoulders. And that way, as it's pushing back, it's actually pulling on your back, and you can control it that way. So that's really gets into the fire hoses themselves. But now we got to talk about actually when we actually put water on the fire. It's important to realize that one water expands greatly once we heat it up. It's 1,700 times the space. So for every drop of water or gallon of water, we're going to fill up 1,700 gallons of space with steam, and that's important because that's going to help extinguish the fire. It's going to help cool things down that much more. And with that, you have to know where to spray. And again, I'm not going to go into a whole lot of detail, but typically what happens is you have a hot layer, then you have a super hot layer. And obviously heat rises, so the hottest area is going to be at the top. When you're spraying water, you want to make sure you spray it just, especially from a fog standpoint, just in the hot gas layer. You don't want to get it up to the super hot. What's going to happen is you'll hit the water here, you'll steam up, and that steam will help bank and cool down the super hot layer at the same time. We start getting into fire stream. It's based on the rate of discharge per minute. So you look, these are 3 different lines, and they're all spraying probably the same pressure, but each one of them spraying a different amount. You have looks like a straight tip nozzle. You have more of a straight stream out of a fog nozzle, and this is looks like it's an apparatus called the Blitzkrieg. That's a 2.5-inch hose. You can see how much different they're all spraying. I don't know why they're spraying near the power lines, but that's neither here nor there. So in order to have an effective stream, there's several things you need to have. One, starting from the far right, you need to have the agent. You need to have the water. If you're not having the water, it's not going to do any good. Then you need a nozzle. What the nozzle does is it focuses the water in one point. We're going to talk about nozzles a little later on. We're going to talk about a couple different types. Then we have the hose, and the hose basically just carries the water for you. Then you have the pump itself, and that just gets the water to a pressure and a volume that's usable. The fire department uses an engine. A lot of industrial areas, they may have a fire pump that charges their system that they can use. So start getting into different types of nozzles, and one is a solid stream from a fixed orifice or a smooth bore. What this does is it's going to get you the furthest reach. It's going to keep things very, very tight together, but you may not have quite as much cooling effect. This is just to put a lot of water onto the seat of the fire itself. What we look at, most of our stuff is going to be within a 10-inch area. You want to use it with the wind behind your back, and whatever that breakover point, that's where it's going to start falling. We want to make sure that our velocity is right. That's going to be coming from the pump. Gravity, we want to aim high enough, and we want the wind to our back. That's going to give us the furthest distance. So that's a solid stream. I'm going to have a video for everybody to watch as well. It's going to explain it a little better than I do. Fog, what it does is it breaks down the particles. Instead of being a solid stream right here, let me see if I can draw this. All right. You see how all the space here, that's all the fog area. It's going to make a very wide berth. If you look at the straight stream by a nozzle, it's going to keep it very focused, and I'm sorry I can't draw really well. I can't draw well anyway, yet alone on the computer. But it's going to keep it very focused, and it's going to go a lot further. The advantage going back going back to the fog nozzle is it can provide cooling for us because it gives a barrier. It also spreads a much larger area, so we can put water on a greater area. It doesn't have the range though. That's where the solid stream is really nice because it gives us a lot more range. So now we look at the types of nozzles we have. These are all different smooth bore, and what it is you see how tight they are. This is all they're going to produce is a solid stream. Because of it, it's smooth on the inside. There's not a whole lot of changes. It doesn't move direction, so it's just gonna go straight out. And this is probably going to give us our greatest distance that we're going to get. Fog nozzles, we got a couple different types. We have our basic nozzle, and honestly, something like this is what we're most likely going to have at in an industrial site. In fact, it may not even be this nice. This one actually has the pistol grip. Most of them I see in industry don't, and I think that's one of the things if they really wanted their people to use them, they'd have they'd pick something with pistol grip. It's a lot easier to hold on to. Then the one on the right, constant gallonage. It's going to give the same amount of flow. The next one over is constant pressure. No matter what the pressure from the engine is going to be, it's going to give you the same pressure coming out. It's going to dampen it, whatever it needs to do. And then you have your constant or select gallonage, where you can make a lot of adjustments. To me, I like these two. They keep them simple. Make a standard fog or solid stream. Otherwise, it's just way too much thinking that has to go on. So, what kind of valve? The most common is the ball. So you see, this is the ball valve in here. As this gets opened up, you turn that solid section, and it goes in line and just flow water. That's the most common. In firefighting. In industry, it's more often that we'll use this. So what will happen is we spin this part, and it'll go down, it'll turn off, or it'll go to a fog. So we'll use this a lot when we're actually on the fire grounds. We'll make sure everybody has a chance to use the hoses. So, now we're going to get into foam. And I mean, there's a lot, 13 slides, but it doesn't. We're just going to really go basics on this one. So there's a couple different types of foams. There's Class A foam, Class B foam. Class B is by far the most common. So what this does, it does a couple things. One, it smothers the fire. There's water in it. In fact, this is called AFFF, aqueous film forming foam. That's what the type of foam is. So what it does is it smothers the fire. It cools the fire from the water. It also puts a blanket of soap, for all practical purposes, a blanket of soap over the fuel, and that's going to be what helps put it out. Class A fuel or foam is a little bit different in that what that's going to do is that's actually going to get penetrate. It's going to get further and further and further into the material. The example here they're using is like a hay bale. You get a hay bale on fire, you get a roll of paper from a paper mill on fire. They're very, very difficult to put out because you can only get water on the outside. With foam, you might be able to get it to actually penetrate deeper where the actual fire is. Typically, it's a mixture. So you'll have your foam concentrate. It's just really, really, really thick soap. The water comes in. This suctions up or siphons up into the proportioner and goes out the nozzle. Now, there's a lot of different ways this can do this. This is probably an overly large proportioner just to demonstrate. A couple different ways to do this. We can use low expansion, mid expansion, or high expansion. This is like if you want to put foam into an aircraft hangar, you use something like high expansion where it just puts tons and tons and tons of bubbles. Low expansions is just going to be whatever comes out of the nozzle. Mid expansions, you're going to get a lot more foam out of this. And again, this is on the video. Class A foam is for Class A. That makes sense. Class B foam is for Class B. Kind of says what it is. Now, depending on what you're using, you may need different foam. For example, this polar solvent, there is alcohol-based foam. A lot of the ethanol plants will have that to make sure that that's covered as well. Synthetic protein, doesn't really matter. So typically what's happened, especially for us, we're going to use what's called an eduction or induction method. So what's going to happen is you're going to have water coming through. You have your pickup tube into your foam. And as this goes, it's going to siphon this all up. It's going to get mixed, and then it's going to go out the nozzle. This is the most common way to do it. Injection, that's if you buy a fire truck, you're going to have that. Then you can also have batch mixing or pre-mixing. Batch mixing is the more common. If you work in a place like a refinery or an ethanol plant or something like that, you may have a pre-mix system that's already charged, ready to go. But typically what's going to happen is you're going to pour the jugs in, or you're going to suck right out of the jugs. To suck right out of the jugs, you use something called an inline foam inductor. It just means here's the hose, here's another hose, and you're basically pulling the foam right out of the jug this way. And it's just going to keep going down the hose line. And then you can get something that you can get an apparatus mounted. I mean, obviously this is a little bigger than anybody's going to have, but it still kind of shows you can definitely have all the foam that you need. You can mix it right there with you. You can also deliver foam with any of these. Some of these you're getting into specialized applications, not something we'll necessarily go into. But definitely a smooth bore or a fog, you can apply foam either way, depending on what the situation is. Now, in order to use this, it has to be applied correctly. So there's three different ways. The first is the roll-on method, and basically you take a look at wherever the fuel is, you hit in front of the fuel, and as you put more and more foam here, it's just going to roll and roll and roll and roll over the entire fuel. You also have a bank down method, and this is, in order to use this, you have to have a solid object. Then you have to have some sort of berm that's going to collect it. So in this case, we're putting foam, it's hitting the tank, and as it hits out in the tank, it's going to start just flowing over the rest of the rest of the material, or the rest of the fuel. And then the rain down method. And this is where you have like an open tank or something like this. And this is you're just pouring it up over and letting it land in there, and you're just putting foam in. You don't want to hit it to any of these too direct, because then what happens if it is on fire, you're just going to spread the fire outside the barrier. So that's really it. Like I said, I'm going to have a video for you guys to watch as well. That's probably going to explain a lot of this even better than I can explain it. But if you have any questions, please let me know.